Welcome back, everyone. I hope you had a chance to have some quick lunch. I know it was a very short while, but we can't wait to get into our next session. Let's move on to our next talk. We have Anand with us. Anand is a true Flipkart veteran, having joined us as a fresher in 2010. He has 11 plus years of experience working with complex techno functional domains related to supply chain, accounting, and finance, seller ecosystem, retail, and planning. And he is currently building retail as a service enterprise suite for large scale retailers at Flipkart. Today, Anand will be taking us through a case study that covers one of the major re architecture journeys in the Flipkart retail ecosystem using principles of evolutionary architecture which enables guided incremental change. Let's have Anand on screen, please.
We'll get started. Hello, everyone. Good afternoon. Welcome back. I hope you had a good lunch break. Today, I will be talking about building evolutionary architecture by taking a retailing platform as a case study, where I would like to share certain key architectural decisions or principles and also key learnings which we had during an interesting re-architecture journey in building this retailing platform. So while we get started, I would like to just probably provide a brief about what is a problem statement or a vision statement we started with. We wanted to build or create a evolvable multi-tenant retailing platform to provide a business efficiency and best-in-class partner experience and to create externalization and monetization opportunities. In a way, we wanted to build a retailing platform and offer it as a services to some small scale, medium scale retailers to carry out their operations. At the same time, we wanted this platform to be evolvable and also should be externalizable to create a monetization opportunities. So what does this evolvable means, right? So in a way, it is asking us to think of ease of change as a one of the important tenant while we start our architectural journey. While we are at evolvability, I will briefly introduce you what is evolutionary architecture. Evolutionary architecture, in a way, supports a guided incremental change across multiple dimensions. As you see, the change is the key aspect which you need to focus on here. While we all know that change is continuous and inevitable, where change could be coming from a technical side of things, for example, the language or the framework or the libraries or the tech support system which we use could evolve or can go through multiple changes. At the same time, the problem space or the domain we operate in do go through certain disruptions. For example, your user demands changes or the stakeholders ask changes, a market or competitor go through certain changes, which forces us to go through these changes, which is inevitable. In a way, it is asking us to come up with an architecture which is resilient to the changes, where it embraces change very seamlessly. It's not just embracing change, it is in a way making ease of change as one of the bedrock principle of your architecture. While I provide this context, I will try to briefly provide an outline of what our journey looked like. Right? The first and the foremost step in our journey was coming up with a functional blueprint. Right? The functional blueprint, in a way, you could see it as it's trying to tell you what is that you want to solve for. It's not just only what, it's about what exactly is the scope of the problem you want to solve. While we all know that retailing is the problem or a domain we are into, but what part of that retailing we want to solve. So this exercise is typically carried out by a product experts or a domain experts by talking to various stakeholders and understanding market and certain solutions which are already available and come up with a certain north star for your product, or in a way you could say as in, this is an ideal product where we want to get to, right? So this is not necessarily a very thorough or a granular way of telling you what exactly you should be doing, but it is giving you a significant requirements which are help you in taking certain architectural decisions. While we know that what exactly or where exactly we want to get to, the other important thing is coming up with an as is view. As we all know, we rarely get to work on something which is a greenfield projects where it is I'm starting from scratch or I don't have any systems to understand or work with, or there are no external systems which I need to understand. That's very rare, right? So typically, that's the scenario for us as well. We already had a certain system in place which is already catering to that certain needs. Now it is very important for us to understand what exactly this particular existing system is catering to. But so the excess in this exercise, we try to assess the existing current systems, flows, understand their integrations, interactions, and try to identify their functional boundaries. So this is going to be helpful to know where you, while we know that where we want to get to, and this is telling you what where we are, right? This helps you in identifying what exactly is the gap between what you want and where you are, right? And this exercise also helps you in identifying whether the existing systems or components can already cater to certain functional or non-functional needs, or certain components has to go through some changes, or some has to be completely discarded and rethought of. So this exercise is going to give you that as is view and a gap, in a way you could say as a gap analysis, right? So third important thing is, while we know that where exactly we want to get to and where we are, so to start a journey of bridging this gap, we have to arrive at certain tenets which are going to guide you, or in a way act as a certain guiding principles throughout your re-architecture journey. In the very initial intro, I talked about in a problem statement, I talked about certain key things like we want our platform to be evolvable, multi-tenant, provide a seamless experience, and we wanted it to be externalizable and monetizable, right? While we talk about these as the key things, so in a way it's highlighting how do you make sure that the architecture or solution which you come up with is evolvable, or makes ease of change is one of the core tenet within it, right? So these usually the tenets are going has to be precise and essential, which is helps you in guiding your architectural journey. The next is the fourth step, where it's about coming up with a certain architectural principles or a decisions which are going to guide you throughout the journey. This is where I'll be spending good amount of time talking about certain key architectural decisions or principles which help us during a journey where ease of change was being addressed using certain architectural decisions and principles. The last and the important step is, while we set up all of this, how do you go about materializing your the view in mind or paper to a practicality, right? It's about walk the talk, what kind of practices we adopted and what were our learnings throughout it, right? While I get started, I'll talk about first architectural decision or a principle which is important, right? So the first architectural decision about high cohesion and a low coupling. While we all know that this is a golden goal every software system or an ecosystem would like to achieve, cohesion talks about a functional strength, or in a way, a grouping of these software components in such a way that they all contribute to one well-defined task. In a way, all are working for a one responsibility, or in a way, you could call it as a single responsibility, right? So while we know that retailing is a very large domain or a problem space, so how do you go about solving this? Usually you break those larger problem into a smaller sub problems, and also these smaller sub problems should be componentized to an appropriate size, and also should be put together so that you are not creating a very granular set of components which is sort of counterintuitive, right? So at the same time, it's not just about complete decoupling, it's also about reducing the coupling between these the components or the modules which you come up with. So this is also important, so that we focus on having a coupling but which is very low, makes your evolution of these modules or components seamlessly down the line, right? So the typical coupling we see is something like a data coupling, where one of the module or component is sharing directly or data with other module. So this kind of coupling is very hard and won't support change seamlessly down the line. At the same time, something like a controlled coupling, where any changes which are being done on one module have a direct impact or an influence on the other module. So we should try to avoid such a direct coupling and minimize in coupling. While I talk about a theory aspect of this particular goal, so how did we get there, right? How did we apply this particular principle in achieving what we wanted to do in retailing platform, right? So here we also adopted certain core principles of domain driven design to start off our exercise. So one of the important aspect which domain driven design calls out is, you have to take your problem space and try to break it down into a core and a generic domains, right? The core domain is something which is very critical or essential to your business. In a way, you could call it as a very unique to a business problem statement you're trying to solve for, or in a way, it is a differentiator. So if you take a retailing domain, you break this into a larger problem, into a very smaller sub problems, which needs to be solved anyway, right? So for example, having something like a demand forecast to understand customer demand, and having a projection or a plan, and having something like an authentication authorization, having an ordering management system, or a fulfillment system, a billing system. While all of these are important problem statements to work with, but are all of these are core, or all of these are differentiated from one domain to another domain? No, not necessarily, right? So when you apply this lens of critical and essential part, you get to see that, oh, some parts of them are very important, which are very unique, which needs to be solved separately for this specific domain, right? These are in a way are differentiators. Take an example of something like an authentication authorization. While we know that this is an important part which you need to solve, but this is not very unique to a retail domain, or a subdomain which you are into. And same is true with the file processing as well. So this exercise helps in identifying your core domains which needs to be solved first, right? So while we know that we have some of these core domains, so the next important step is how do we logically consolidate these smaller sub problems so that we achieve a high cohesion. So it's not about we end up solving this problem in isolation, right? That end up leading to a state of where we have completely a decoupled architecture, which is not good for change agility, right? So the subdomain exercise is all about logically grouping these smaller subproblem spaces, right? So in a way, you could get a certain cue from how your business functional are grouped, right? So that you could logically group these smaller subproblem space into a subdomains, right? But to make it a bit more simple, we come up with a certain framework where it helps you in identifying how do you group these smaller sub-problem space. You take a certain problem or a solution space. You have to identify certain key stakeholders or business users who are going to work with this particular problem or a solution space, right? So the other next dimension is you have to identify what kind of external systems or an integration touch points which my problem has to deal with to solve for it, right? The third dimension to this is going to be area of expertise. What kind of expertise needed to solve this problem, right? So if you're able to identify these three pivots for any given sub problem, it in a way tries to give you uh, how you should go about identifying your subdomains. So if I apply this framework to something like a retailing domain, which I just talked about, where we identify these as a core domains, or in a way call it as a core problem or a solution space, the first exercise was to identify stakeholders. For example, for understanding customer demand or coming with a projection or a plan, the stakeholders like inventory planning controllership has to work with us. Something like an ordering or a requirement management where we need a vendor operations or a category operations, or something like a fulfillment or a consignment dealing thing, we need to work with the vendor operations or warehouse operations. Something like invoicing and payments or a billing, we need to work with the finance users or a legal and a taxation, right? So once we have these users identified, next thing is you have to identify those external ecosystems which you have to work with. For example, for the first one, it will be a forecasting system. The second one will be vendor contracts, ERP system. The third set would be like warehousing system or a fulfillment systems. The fourth is going to be like billing system, reporting system, right? Pivot is what kind of expertise is needed, right? The first pivot is mostly like it's a data engineering or a data science or an optimization kind of an problem space. The second is more about workflows, contractual validations. The third is about fulfillment, logistics, execution, and fourth is more about accounting and reporting, right? So while you have identified these three pivots for each of these problems, you next exercise is to find out those group with a minimum overlap. While you see there are certain overlaps between each of these, for example, vendor operations is overlapping between multiple subdomains, and same is true with a certain external touch points as well. So there will be a certain overlap, but you have to identify those groups with a minimum overlap so that these stakeholders or external system need not have to go through understanding or hopping between multiple teams or systems, right? Once you apply this view, something like this emerges out, right, where we are able to identify these core subdomains which are logically Some of these subproblems are logically grouped, right? The same framework could be eventually applied when your existing subdomain is being broken down into multiple subdomains as and when your stakeholders increase or external integration touchpoints increase. So this in a way helps you as and when the change hits you, as and when the domain evolves, the exact framework could be applied to further arrive at the granular size of these subdomains, right? So in the this is how as and when your domain grows, there were multiple subdomains we were able to identify and also logically group smaller subproblem spaces within it, right? While I talked about something called as a core domain, the next important thing is a generic domain. So as the name says, these are going to be something which are contextual business, right? But as engineers, typically for us, something like a meta work looks more interesting than the actual work, right? While I say this cliche, why I'm trying to say that is, so these are generic domains which are an important problem to be solved, but these are not going to be very core to our business. These are in a way facilitate the business, right? These are usually generic in nature and typically commonly solved in one place. What it means is these problems needs to be solved in each of the sub problem, but need not be solved very specific to that sub problem. They could be gathered and solved in one place. So or usually there will be some solution which already exists maybe within your org or maybe outside, which could be straight away leveraged or bought from, right? So how do you identify the generic domains? And as I said, this is not the first thing you should be solving. You need to analyze various use cases within those subdomains and try to identify common patterns which will in a way give you what exactly these problems needs to be solved and how it could be leveraged across, right? So the same exercise when we did for retailing, right? So typical things which you see, which I'm quoting here, is something like a file processing system. So typically to carry out certain bulk operations or heavy operations, you need to feed input in a file or so that it could be processed in a batch or a bulk fashion. So this is not going to be very unique or specific to each of the sub problem, while it has to be done in a common way. So it is better, the all the use cases or the patterns are being put together and solved in one place, and it could be leveraged seamlessly across all. The same applies to something like a business rule management system. Same applies to something like a notification system, something like a business process automation as well, right? So while I talk about that, I would like to share certain key learnings, right? So at the first glance, when you look into some of the sub problems, everything looks like, oh, it's a service, I have to make it as a service. So this leads to a premature state of coming up with a microservices. Or if you say that no, everything could be solved through the same entity, or everything could be solved by these services, you will end up creating something called as a god entities or god service, where it tries to achieve everything, right? So the ways we should go about solving this is, while we know that these entities are important, you need to segregate these entities in such a way that what is domain entity, what is data entity, and what is value objects, right? To simplify in coming up with this exercise, right? So this is what you can apply, right? You could put it in a matrix where domain entity and its properties and data entity and value objects, right? While we know the domain entity is very core and very unique to this problem statement we are solving, which has its own identity in the domain space, and it also goes through changes, and it has its own life cycle, which is directly being influenced by the domain you are into. While if you see a data entity, it has an identity, it also goes through changes, but its life cycle is not directly being controlled or influenced by the domain you are in. Typically, you take a scenario where you're holding the data from some external system or a dependent system, where it has an identity and it is going through changes, but the life or the life cycle or the state of that particular entity is not being controlled by you. So in such a cases, you need not go and call it as, oh, well, I'll expose a service on top of it. Usually these are data entities which could be referenced or consumed maybe by caching this data rather than having to offer a service on top of it. Same applies to value objects, where it's an identity, has an identity, it does not go through changes. Usually you create a new value object as and when you need, and does not have a life cycle. So usually these need not be offered as a service in itself. This could be tied up directly to your domain entity and should be solved together, right? So quickly I'll move on to next architectural decision, where I'll talk about reduced integration complexity. While I in the beginning mentioned that ease of change is one of the important pivot which we want to consider. So this is going to be helpful in achieving so, right? So as we all know, the moment your external touch points or integration touch points are high and complex, it makes the change a bit harder. The change agility goes for a toss, right? So if I take a retailing platform, obviously it has to interact with the various external systems like a planning or a forecast ecosystem, fulfillment ecosystem, accounting platform, or a marketplace ecosystem. And our own retailer hub is like an user interface where vendors and retailers comes and interacts with this platform, right? Why I'm calling this an ecosystem, these ecosystems are themselves a cluster of certain services, right? And same is true with the retailing platform, where it also has a cluster of services. Should one of the approach to make these interactions happen is these the service the underlying services within retailing platform directly interacting with the services of this ecosystem. So by that way, you are unnecessarily introducing a integration touch points, right? So one of the approach we adopted here is using something called as an API gateway pattern, right? API gateway helps you in compressing the public interface. What it means is, what information or an service which you're exposing outside to your clients has to be very minimal and simple, right? And at the same time, you're not directly exposing your underlying service APIs or a data as is, right? So this allows you in making these particular APIs or a data customizable and composable as per the client need. And at the same time, you also have a control on what exactly you want to share, like what kind of API you want to give or what kind of data you want to provide, right? In other cases, you are unnecessarily throwing everything which is available at that particular service, which may create an unnecessary dependency or unnecessary complexity by integrating directly on that case, right? At the same time, as I was telling, if your system is going through certain changes, you may have an old system and you may have a new system. Do your external system how to understand which system to call in what case, right? That is very unnecessary and also creates unnecessary dependency. So this also helps you in abstracting out how your internal service partitioning or breakup could be completely abstracted from the external clients. At the same time, how your internal service also need not understand certain complexity associated with an understanding or interacting with an external systems, like what kind of clients I have to understand, what kind of contracts these existing system has to go through, that could be completely abstracted out by this API gateway layer. And also it could address you certain common concerns like authentication, authorization, client provisioning, rate limiting or throttling, or as I said, when to call which service, and also provide certain debuggability and auditability concepts as well. So if when we apply the same thing to retailing platform, we end up taking this approach where every external ecosystem which we interact with has to go through a gateway. So once again, you see here, this is not a one gateway for everything, right? So in a way, you should not be ending up encouraging a god services or a monolith, which is once again will put you into a situation where it makes your changes very brittle and hard, right? So a domain specific or an ecosystem specific gateways helps you in making the interaction simple and also abstract out all the nuances of integration as well from your internal services. The third important thing which I want to move towards is layered abstractions. So typically, you will have a business users, or in a way they will be working with the business functions and underlying service units. Let's say when I want to create an order. So while we know that order creation could be just like in one operation to a business user, but under the hood it has multiple small things like I need to check an inventory, I need to check for serviceability, and I eventually have to store an order. Same is with the dispatch order, right? So let's say if I want to dispatch an order, I need to reserve an inventory, reserve a service, and do an handover, right? So when I play a scenario, let's say I want to dispatch an order, I reserve an inventory, and that goes fine. But when I want to reserve a service, let's say you hit a scenario where it fails because of certain technical or non-technical reasons. So now you can't leave it at that stage because your inventory is at a inconsistent state. You may have to issue a certain compensating call to correct that, right? So while I take a one scenario, if in a typical world, this business functions is very complex. This could be a multiple of such business functions, which could be configured in a very complex flow. Same is true with underlying service units. So should we be directly exposing these underlying service units to a higher order utilities like a business functions? This unnecessarily creates a dependency which once again make any change which you do in a business flow has to have a change in underlying service units, and other way is also true. In order to avoid this, we took an approach of introducing another layer of abstraction to decouple these higher level flows from lower level utilities. So this allows you to decouple how your business should be configuring and composing their business workflows from your underlying service units, right? So you are not expecting them to force fit their business as per what your underlying framework offers, right? And also, as I said, each of these layers have their own velocity of change or volatility. So each of these changes should not directly or indirectly impact too much on each layer. So the approach we took is something called as a three-layer approach, where the underlying layer is something you can call as an small lower level utilities which have been exposed via well-defined interface or APIs. The upper layer you see, it's like a higher level business functions or utilities, where business function can use multiple of those and could be wired to achieve their goal, right? So in order to decouple these, we introduce another layer called as service orchestration, which allows you to create and compose a coarse-grained smaller coarse-grained business services which could be directly used by your business processes, so that they don't have to understand the nuance of managing these lower level utilities. You could simply map it like, okay, you have a smaller blocks which needs to be put together in preconceived structure, so that these structures could be directly used to build a larger shape. You could very well expose these lower level blocks to build a structure, but every time you want to do a change in each of these will have an unnecessary implications on the other layer. So this way of decoupling helps you in making your each of the layer resilient to the changes. The fourth important architectural decision which I quickly would like to cover is about anti-corruption layers. So typically, when we come up with when we start a journey of, okay, I have to replace an existing system with a new system model, but you will have a scenario where it has to work with a legacy system or an external system model, right, to carry out certain operations. But as we know, the model of your new system may not directly conforms to the legacy system or an external model. They may not be compatible, right? So the ways to solve this could be either you expect a legacy or an external systems to build that layer of understanding this newer model, right? Or you would have to make your newer system model conforms to the model which your legacy system or external model. So both of them are not encouraged, because you are leading to a certain compromises in case you are expecting legacy system to do changes that may not be feasible. So one of the recommended approach here is you will introduce a throwaway layer, which is called as an anti-corruption layer, which helps you in making avoiding your the newer system model compromises on the design which you have set up. All of that overhead of translation or a conversion could be completely transferred to this ACL layer, which makes the interactions compatible with your legacy or an external system, right? So typically you play the scenario when you have a bounded context where it is expecting to support a different model altogether, right? Where you are not adhering to the model which it is providing, and at the same time your upstream model may not be efficient, or it could be inconvenient, or it may be going through a frequent changes, right? So this helps you in provide building this layer so that you don't wire too much into an external component or a module, right? And these anti-corruption layers are just in time to insulate against any overhead of changes being done from one to another, right? So as and when that maybe a legacy system or an external system is taken off, you could completely throw away this ACL layer, so that your newer system still remains unimpacted with respect to its design, right? So this is once again towards making your architecture resilient to the changes. The last point which I'll quickly cover about is avoiding the needless variability. So typically you take a business scenario where you will have a very complex flow of operations and certain approvals which are going to carry out certain operations. For example, I want to a retailer approval in scheduling certain consignment. I may need a vendor approval in doing certain operations and so on. And usually they also go through a quick changes where I may want to introduce another layer of approval, right? How do you go about managing this frequent changes? Would you expect your underlying domain services or an entities to carry out this state as is? If so, as and when the business flow or state changes, you're expected to do this change. Once again, any change in this layer is directly percolating into your lower layer. So the approach we took here is the way we model our life cycle of these domain entities is simple and short. And also we decouple these business flow states from your underlying core entity states. So this helps you in making sure that as and when a new state or a business flow state is introduced, the same state may not be directly introduced or introduced to your lower level entity, right? So and at the same time you have to make your entities immutable after certain layer, so that you could leverage this fact to make a right tech choices. The simple state flow which we went with is something like this, right? We have a created state and an approved state and approved to completed, where it can also be, you can also reverse the impact of this by canceling and creating a new entity rather than trying to modify the same entity. So if you have this immutability as a key, you could very well use this fact to make a right choices for your data store, where you can have a very short simple hot store where it is allowing you transactional read and write. But once that particular entity reaches a state where it is becoming immutable, you can completely move to a state, move to a tier where it is only available for read. So you could make appropriate choices as per the access patterns. And same is true with the cold tier, where if you need it for just bulk read or async read, you did not try to provide all of these from a single tier, which once again makes your architecture very brittle as and when the data grows, right? Same you could be applying for an business facts, right? So the last and important thing which I'll quickly touch about is, so whatever we talk about architectural decisions, design decisions, now how do you go about materializing this? It's all about people, right? So I'll quickly talk about key four learnings, right? The first important learning is encourage iterative solution design reviews. Don't try to get everything right in the first place. Emphasize on having a design focus where you are targeting something which is clean and idealistic, but during the execution you make it more pragmatic or incrementally in a way. The second important thing is we have to invest in practices where encourage a bottom up culture. You set up a forums and working sessions where engineers can come validate and discuss, align the differences in the expected versus what is happening on the ground, right? The third important thing is, while we build certain solves, we know that this is going to take time. It is better we have a early validation or a feedback from directly from the users or the stakeholders which we work with. The fourth and the foremost important thing is, while we have worked upon breaking this larger problem statement into a smaller functional domain boundaries, how do we go about aligning these teams and team boundaries, their process and practices in line with what the domain boundaries we have established, right? So this is going to be also very important while we work with people, or else it creates an unnecessary confusion and overhead, right? So that's it from my sharing. Thanks, and for question and answers. Manohar, any questions? Uh, I'm just waiting for if there are any questions from the audience. Guys, I hope you found the session useful. And if you have any questions, you could very well reach out to me in the networking launch as well, where you can connect us. So I see a one question. We use the core domain to define a common data models across services to reduce duplicate code and consistency. The version of this core domain is defined across services. But in case if of any change in core domain, then what is the best practice? So it's an important question, right? So where we are talking about, so the core domain which you're coming up with could be also shared across multiple use cases or so, right? And typically we try to solve this in a common place. So see, the important thing here is the even whether it's a core domain or generic domain, they are going to go through certain changes. As and when the change happens, the corresponding thing has to be handled as well. But if you're seeing that this core domain itself is frequently changing, which is sort of creating a conflict between multiple use cases, then in a way it is trying to signal you that we haven't got the decoupling right, where certain things are still tightly coupled. These are the signal we should look for to further break down this core domain, so that these stays relevant to all the use cases. If this particular problem statement or a feature is looking very specific to a particular part of the problem, then it is telling you to further break this problem, further break this core domain into a smaller subdomains, and you could try to solve them independently. But if the changes are very less frequent and that has to be handled, this in a way should be handled very gracefully as a domain evolution in a way, right? Thank you guys. You could very well reach out to me in a networking launch as well. If you have any question, I will be available there for 15 minutes.